In this lecture, I am explaining about the uniform density function. Okay, so this is one type of density functions. So here, the uniform density function is expressed as small f(x) of x is equal to 1 by b minus a. Here, b and a are constants. Here, the range is a is less than or equal, x is less than or equal b. Okay, so that means the x value ranges between a and b only, is equal to 0 elsewhere. What is the meaning here? So between the x value is in between a to b, then the density function is 1 by b minus a. Otherwise, the density function is 0. Here, where a and b are real constants, here a is taken in between minus infinity to infinity and b is taking always greater than a. Okay, here 1 by b minus a. In this, a and b are constants. That's why totally the density function for uniform density function is constant. Okay, so for this we are calculating the uniform distribution function. So how to calculate the uniform distribution function? Already we know in the properties of probability density function, capital f(x) of x, that means this is the probability distribution function, is equal to integration minus infinity to x small f(x) of x dx. Here this small f(x) of x is the density function. This is the relationship between probability distribution function and probability density function. Already we know the uniform density function in the above expression, that will be substituted here. Capital f(x) of x is equal to integration. What is the range here? A to b. In this, the lower range is a and the upper range is b here. So in this integration minus infinity to a, 0. The density function is 0. That's why we are considering the density function from a. That will be the lower range. That's why here the lower limit is a and the upper limit is x. Because here in this bracket we need the probability distribution for x only. That's why the upper limit is x. And the density function is 1 by b minus a dx. Here 1 by b minus a is constant. That's why the integration is x by b minus a. What are the limits? A to x. By substituting the upper limit x minus, by substituting the lower limit a, x minus a by b minus a. This will be the uniform distribution function. Okay. Suppose if you are substituting x equal to a, in this capital f(x) of x is equal to a minus a. Instead of x we are substituting a minus a by b minus a. That will be 0 by b minus a, that is equal to 0. Suppose if you are taking x equal to b, then capital f(x) of x equal to, in place of x we are taking b minus a by b minus a. That will be cancelled both numerator and denominator, then we will be getting 1. Okay. So here finally we are getting the probability uniform distribution function is 0 when x is less than a, x minus a by b minus a, in between the range a and b is equal to 1, x greater than or equal b. Okay, so always the probability distribution function final value is 1. For this density function and distribution function, now we draw the plots. How to draw the plots? What is the density function? 1 by b minus a. 1 by b minus a means constant. That constant is in between the range a and b. That's why on x-axis we are taking the x, random variable events. On y-axis we are taking small f(x) of x, that will be the uniform density function. Here between the range a and b, the value will be constant. That constant is 1 by b minus a. This is the plot for uniform probability density function. Now uniform probability distribution function. Here between a and b, below a, x is less than a, what is the uniform distribution function? 0. Between a and b, the uniform distribution function is x minus a by b minus a. That will be linearly increasing graph. X greater than or equal b. That means at x equal to b and greater than b, we will be getting the distribution function is 1. So, by using the expressions, we draw the plots for uniform probability density function and uniform probability distribution function. Okay, so here the uniform probability density function has a constant amplitude in the given range. Constant amplitude in the given range. The total area of the function is always 1. Okay, the total area is always 1. Now, what are the applications for this uniform density function? So, there are two applications. The first one is the random distribution of errors introduced in the round-off process are uniformly distributed. That means the errors are uniformly distributed. Okay. The second application is in digital communications also we are using. How means in digital communications when a sample of the signal is rounded off to its nearest level. Okay, the sample is rounded off to its nearest level, then we are using this uniform density function. Or suppose if you are taking in a game, when a real number is converted into an integer, then the probability density function of errors are also uniformly distributed. These are the two applications for uniform density functions. Okay.